Hey people, Cranksome here, making another video, how-to video on Mower modification. This modification is going to be for mowers with bagging systems on it. Basically going to improve the suction power on the mower. It'll pick up more debris coming off the ground, like little rocks, little chips of wood, some garbage. You could even use it to vacuum your sidewalk. That's how good it works. Plus, if you have a little chihuahua, you'll never pick up the little poop before you cut the grass again. They'll suck it up. Okay, what I'm going to be doing first is the modification on a push mower. Push mower is a snapper. Nothing special about it. 3.5 horse with a bagger on it. It's the only way you could run this mower. You can also do this modification on a riding mower with a bagging system on it. That'll be part 2 of this video, a separate video. So I'm going to focus on just doing the snapper first, show you how to do it. Okay, when I come back I'll have the parts all set up. Okay, I got the blade out. Quick look at the blade, you'll notice that it's got weld marks on the tips. I already did this modification to this mower once, but the tabs broke off because of the crappy weld job I did, or it hit something, or for whatever the reason. But first blade identification would be this looks like a mulching blade. Mulching blades have the wingtips on the ends, plus they got little down wings in the center of it to create a whirlwind effect inside the chamber to recut the grass after it gets chopped off the ground. So this modification will work with any kind of blade, doesn't matter what kind of blade this is. So what I'm going to do is clean up the welds so I can re-weld it. You also want to inspect the blade for cracks. If you notice too, the tip of the blade's pretty beat to hell, so I'm going to resharpen it too since I got it off. I usually sharpen it from the tip all the way to almost the center, just for the hell of it. So I'll be back. Okay, I inspected the blade. The only thing I noticed wrong with the blade is it's got a thin spot at the wingtip right at the bend. I figure I'll just weld it up. That's the spot where all the dirt and debris hit, so it wore it down. I'll just weld it up, add more metal, it'll take care of it. I'll do the same thing to the other side to help balance out the blade when I'm done. So back to the modification. I'm using flat stock, 1/8 thick, 1/8 of an inch thick, 1 inch wide, plain flat stock from Home Depot. I got it. What you want to do is you want to make this wing tip taller, and I'm going to bring it over to here. So basically just adding a bigger wing to it. Cut it off right here, give it a nice angle here, which is going to leave a gap here. I'll probably add a piece of metal there to take up the gap. And let's see, I'll mark it. What I'll do is I'll cut this piece out, lay it on here, mark it again for the other piece, and which will bring the pieces to be identical, well, close to identical. I'll grind them down with a pair of vice grips clamped together to make sure they're identical for weight balancing purposes. So when I come back I'll have the two pieces cut with the angle on it matched up, ground down, and ready to tack weld onto the blade. Okay, I got the two pieces cut out. I'm showing you this part in detail because it's going to help later on when balancing the blade. I take the two pieces, set them side by side. I clamp them with a pair of vice grips so they don't move. What I'm going to do is take the grinder and just grind the edges to make sure they're both even. That way they'll be both identical, which means they'll be identical in weight too. And any other pieces that you weld on there, you want to do the same thing. You want to match them up like this, grind them down so the balance, so they weigh the same, well, basically identical is what you're shooting for. It'll make it easier to balance out the blade when you're done. Okay, I got them ground down all the way around the edges except for where the vice grips are. If you notice, they're going to be even, so that means the weight's going to be pretty close to being the same. Okay, now if I were to use these two pieces, the two pieces that I cut off, for something else, one on one side, one on the other, I would have to do the same thing to these two pieces just to help with the balancing process. Okay, next step would be to tack weld these two pieces onto the blade and check for clearance. You want to mount the blade back up in the mower and spin it to make sure it's not going to hit the deck. When I come back, I'll have these two tacked into place, and then I'll give it a spin on the mower. Okay, I got the prop mounted. I'm doing a clearance test. This is the lowest part of the deck, and I notice this side's hitting. I push it through to the other side clears it, so that means the blade's hitting. The blade must be bent on this side. To straighten out the blade, I'm going to mount it in a vise. The jaws will be from here to here. This will support the center and the edge that's not bent, and I'll grab this side and I'll bend it straight. This is an accredited method. They do this on boat props and aircraft props, so beats buying a new blade. When I come back, hopefully I'll have the blade straight. Okay, I got it bent straight. As you can see, this is the good side. It doesn't have the mark. That's the bad side. If you can see the notch, the black line I made on the cardboard, it's right up against the blade tip. So when I spin it around, recenter it on the fitting, it's in the same exact spot. Okay, this is not a proven method. It's not a guaranteed way of doing this. This is just done to keep me from running up and down the stairs and mounting it and remounting it to see if I bent it the right way. This is just a quick reference to get the job done quicker, so when I mount it back up onto the mower, I'll show the correct method, the proven method, to making sure that the blade is not bent. Okay, I got the blade mounted. Checking for straightness again. The correct way to check for straightness would be to mount it on something. In this case, it's the hub itself. It'll make sure it's centered and it's on a flat mounting surface, which is where you mount it at. So to check for straightness, you basically just need a reference point on the side of the blade where you can make a mark. I don't know if you can see it. It's kind of sunny. Okay, then you match this mark onto the blade where you made the mark as a reference point, which is this tip right here, and you notice that it lines up with it. So when I bring the other side, it's just below it. So the blade's still off just a hair, maybe an eighth of an inch. So you notice that the method that I used when I straightened it wasn't that accurate. This is more accurate. So I got to take the blade back off and bend it some more. Okay, I'm back. I finally got the blade straight. Lining it up with the mark, with the tip for the other blade. Same spot. Okay, while doing that, I actually broke all the spot welds off to one side, the old tabs off. And this one, I busted this side, so I got to retack it. And then I could weld them into place. I know that the blades will clear. As you can see, that's the lowest part of the deck, and the blade clears it. There shouldn't be any bending while it's running, so it won't tap it. I'll do that next. Okay, I'm back on the blade. I got the blade extensions tacked on there. As you can see, it's the same angle as the original blade of the mower. You're just basically extending them and making them longer. The only way you can make them longer is inwards. So I got that side tacked. Then I got this side tacked. Now I'm going to final weld them in there, and I'm going to clean up the welds and then fill in this gap here. I'll be back. Okay, I got all the pieces of metal cut out and ready to get welded. This little piece of metal is going to take up the hole. Slides right in there. Weld it up. This piece is going to go on the edge. What this piece does, when the air hits the blade, it'll cup it instead of it hitting the blade and being thrown out to the side. It'll make the blade more efficient. Airplanes use this on their wingtips. You ever notice airplane, they got wings on the tips of them going up? That's what this does. It actually cups the air, and if you notice too, I clearanced the edge here to where it doesn't go past the edge of the blade. That way I don't have to worry about any more clearancing issues. So I'm going to weld the parts up, show you the finished product, then I'll put it on the mower and do a test or two, show you how it works. Okay, I got the blade done. Got everything ground down. I even got it sitting on the balancer, so let's see. Actually didn't have to balance it. I just cleaned the welds off, got rid of the splatter. I didn't grind down the welds too much to weaken it. But that's the blade modification. This is going to catch the air, more air because the blade's bigger. This end piece going up is actually going to cup it, make it more efficient. Like I said before, airplanes use this technique on the ends of the wings. Makes the wings more efficient to lift more weight. So you ever see a big airplane that's got the vertical ends on there? That's what it's for. Makes the wing think it's longer. So a little bit of airplane technology there. I'm basically thinking of this as a spinning wing, so that's where I got the idea from. So I'm going to hook it up, give it a quick test before the storm comes in again. It's been raining all day, everything's freaking soaked off and on. I've been working on this in between the rain. So, okay, I got the blade in. Spins free, but I did have to clearance the housing anyway, because after welding it, it probably bent right back to the bad position. I had a hell of a time bending it anyway. This blade is made like a freaking leaf spring. Bending the spring is challenging in itself. So if you notice too, when I spin it, that would be the high side, and the low side. That's the side that would be hitting the housing. No, the other side. I don't know. Somehow they reversed. Maybe the shaft's bent. I don't know. Yeah, I think the crankshaft's bent. Oh well. Let's try the modification out. If the motor doesn't run smooth, then I guess I'll be changing the motor. But it should run smooth. I balanced out the blade. It should run okay. Thing's just idling right now and the bag's full of air. Well, it does work, so I gotta change the motor. It looks like the crankshaft's bent. suck up that puddle. Can't rev it too high, the crankshaft's bent. That's where the vibration's coming from, so looks like I'm putting a new motor on there. But the modification works. It's a pretty good test at sucking up the puddle. So, and that was right at the line where I had the throttle right there. That's where the baseline was when the bag just started to fill up with air. So it's working. Next video will be on the riding mower. That one there with the bagger on it. It's going to help suck up anything and everything. You'll also be emptying the bags a lot more since you're sucking up everything. You're practically vacuuming the yard. That's the only drawback. You'll be dumping a lot of dirt. So rate the video, comment, subscribe. Pranks the man. Bye.